Number 14. Select the graph that corresponds to the equation y equals negative 2 x minus 4 squared plus 2. Now, because I see the squared, I know that this is a quadratic. This is actually a quadratic in something called vertex form. So I'm going to write down all of the things that I notice because of this equation. So because of that exponent of 2, I now know this is a quadratic. And it's a quadratic in vertex form. And we'll talk about that. Vertex form of a quadratic has this parent function form. Y equals a parentheses x minus h squared plus k. Let's talk about each one of these variables. Now, the a is going to tell you if you have a quadratic that opens up or opens down. Your quadratic will open up if a is positive. Your quadratic will open down if a is negative. You've heard these referred to as a parabola. Parabolas are quadratics once they're graphed. Now we have some other variables that we need to talk about. H and K. Now, H and K are going to be your vertex. It's going to be the turning points of these parabolas. So your vertex, which is why they call it vertex form, your vertex is the coordinate H, comma, K. So the two letters H and K will give you your vertex. However, it's a little tricky. The H is a little bit tricky. You have to make sure you notice you're taking the opposite sign of what's in the parentheses. So just make sure you're recognizing this is the opposite sign. So what does that mean? That means that in your equation, we have a couple of pieces of information that are very important. The negative 2 will tell you if it opens down or opens up. Since it's a negative, we took the note that it's going to open down. It's going to be facing down. So you're going to have a quadratic facing down because of that negative. Now that means your answer is not going to be graph 1. It's also not going to be graph 3. You're either going to select graph 2 or graph 4 because there's a negative there. The next thing is the only difference that you're going to look for now is the coordinates of the vertex. So in our equation, we notice there's a negative 4 and a 2. Now, the key is you always switch the sign of the number inside the parentheses. So the negative 4, make it a positive 4. The 2, keep it the same. Keep it exactly what sign it's listed as. So we're going to keep the 2. But the 4 did change signs. So your vertex should be a positive 4, 2. So let's find it on our graph. 4 up to 2. This is our graph. Now the other option was negative 2, 3. Well, 3 isn't even part of our choices, so that wasn't going to be our answer. But they could have tried to trick you and had this at negative 4, positive 2. And you would have selected that if you didn't know that you have to change the sign in here. Okay, so make sure you have all these notes. The first number in from the parentheses, whether it's positive or negative, is going to tell you how to have your parabola. Facing up if it's positive, facing down if it's negative. And then the number inside of your parentheses, if you change the sign, is going to be the x coordinate for your vertex. And then the number at the end, do not change the sign, and it's going to be the y coordinate for your vertex. Let's move on. Number 15. Here we have a word problem, but don't get scared by it. Let's read the word problem through one time and then go back and pick up some important information. Number 15. Mr. Brown lives in Key West, Florida. The recent winds in the area have destroyed the fence around his rectangular property. The figure below represents Mr. Brown's backyard. Find the polynomial expression that would represent the perimeter of the fence. Okay, that was one time through. Let's go back. Mr. Brown lives in Key West, Florida. All of that is unimportant information. The recent winds in the area have destroyed the fence around his rectangular property. I do care about the shape. Now, the reason why I care about this shape being a rectangle means the top and the bottom are going to have the same length. The left and the right side are going to have the same length. So 3x squared plus 4x plus 2, I'm going to also put that down here. 3x squared plus 4x plus 2. Because the top and bottom of a rectangle have the same length. Same thing for the right and the left side. So if this is 2x plus 3, then this is 2x plus 3. That's the only thing I cared about in that sentence. The figure below represents Mr. Brown's backyard. Well, I know that. So not important. Cross it off. Knock it out of there. Find the polynomial expression that would represent the perimeter of the fence. Find the polynomial expression. So they're asking you for an expression. They're not asking you to solve for x. They're just asking you for an expression, which right here, that's an example of an expression. It's just a couple of terms being added or subtracted together. They want a polynomial expression that would represent the perimeter of the fence. Perimeter is when you add up all the sides. It could be a triangle, it could be a square, but perimeter means add up all the sides that make your shape. So in this case, we have 4 sides. We have to add them all together. Add. So let's start writing out all the things that we're going to be adding together, okay? Actually, since we already have them written here, let's do this. Let's just look for like terms. I'm going to start with the largest degree, which if I look, is going to be the x squared. So I have a 3x squared here. And I have a 3x squared here. There's no more x squareds. Okay, so 3x squared plus 3x squared is going to give me 6x squared. Next, let's go to the regular x terms. I have 4x, I have 2x, I have 4x, and I have another 2x. So we have to add all of those together. 4 plus 2 is 6. Plus 4 is 10, plus another 2 is 12. So one more time, I'm doing 4x plus 2x plus 4x plus 2x all together. 4 plus 2 plus 4 plus 2 is 12x. So plus 12x. And lastly, I have some whole numbers. 2 plus 3 plus 2 plus 3. 2 plus 3 is 5, plus 2 is 7, plus 3 is 10. So again, I did 2 plus 3 plus 2 plus 3, and I got 10. So plus 10. That's it. I've used up all my terms. The perimeter, expressed as a polynomial, is 6x squared plus 12x plus 10. Remember, perimeter means you add. Perimeter, you add up all the sides of your shape. Okay, we're done. Next question. Number 16. Another word problem. We're going to read it through once and then we're going to go back. Maria has worked at a dental office for many years. Her starting salary was $37,500 and received a yearly pay raise of 4%. Her yearly salary can be modeled by the function S of x equals 37,500 times 1.04 to the x power. How would Maria's salary function be different if she had a 6% yearly raise? And part B, how would Maria's salary function be different if she took a 3% pay cut each year? Well, let's go back. Maria has worked at a dental office for many years. That may be great for creating context, but that doesn't give us any information. Her starting salary, the beginning, was $37,500 and received a yearly pay raise of 4%. A yearly pay raise of 4%. Her yearly salary can be modeled by this function. Notice they use the letter S. They use the letter S probably because they're talking about a salary. Salary as a function of time, because each year she was getting a raise of 4% from the prior year. So her function uses $37,500, which notice is the beginning amount that she was first getting paid when she started. 1.04 is the base to the power of x. Now notice that 0.04. Where does that come from? That comes from the fact that 4% was her yearly raise. You always use your percentage, your rate, as a decimal. So to turn 4% into a decimal, right now it's 4.0, you're going to move your decimal to the left 2 units. So you're going to put in the 0 right here. So 4% is equal to 0.04 as a decimal. Now, whenever you see things about yearly pay raises or yearly decreases, the word yearly and annually, they're telling you about a specific type of exponential function, a rate function. A rate function will look like this. It's going to say function of x, and it could be any letter here. S for salary like they did, R, P, whatever they want to use. Profit sometimes uses the letter P. So f of x equals your principal amount, your starting amount, times 1 plus your rate as a decimal to the x power. Now I want to put some notes into here. P is your starting amount. Sometimes you'll hear this as a growth and decay function as well. But P is your starting amount, whatever you started with. R is your rate as a decimal. Now this function is only if you are increasing annually. If you increase annually or yearly. We have a different function if you decrease, which we're going to write now. So for the second part here, I want you to write, if I was decreasing, if my value was going down, maybe it represented the cost of a car that over time goes down because it's not worth the same as when you first buy it. So if your cost goes down, it's going to be f of x equals the starting amount, P, parentheses 1, minus your rate as a decimal till the x power. So same thing, this is going to be an exponential function, but for something that's decreasing. So if you decrease annually or yearly, decrease. And again, same thing, this is the starting amount. And then the rate needs to be as a decimal. So rate as a decimal. So those are your notes. Let's go back and answer the questions. So for part A, how would Maria's salary function be different if she had a 6% yearly raise? Well, the only thing that would change would be the rate. It's still going to be a starting salary of $37,500. It's just going to be a 6% increase, which of course we all want, 6% yearly increase. So our 6% as a decimal, remember what you do. Right now it's 6.0. You're going to take your decimal. You're going to move to the left twice. So as a decimal, it's 0.06. So your function would look more like this. S of x, because they used S instead of F, equals 37,500, parentheses, 1 plus the 0.06, so it's 1.06, to the x power. Part B, how would Maria's salary function be different if she took a 3% pay cut? So that means it's going down. You're decreasing every year. I don't know why you would want to stay at that job, but you would be taking a pay cut each year. Well, you're going to be using this function that decreases annually. So instead of adding your rate, you're going to be subtracting the rate. So how would this look? Well, S of x would equal same principal starting amount of $37,500, right? Parentheses, 1 minus 0.03, because it's 3%. So remember, 3% is equal to 0.03. If we express it as a decimal, you have to move it twice to the left. So 1 minus 0.03 to the x power. So 1 minus 0.03, you're looking at 0.97. So we're going to just simplify this one step further. 37,500, 0.97 to the x power. So you'll notice a difference. When you're increasing annually, you're going to have a number here that's larger than 1. When you're decreasing, you're going to have a number here that's less than 1. Okay? We're done. Let's move on. Number 17. Y equals 2x squared minus 4x plus 5. Graph it. Well, we're looking at a quadratic because we notice that it has an exponent of 2, so it's a quadratic. But this quadratic, unlike a previous problem, is not in vertex form. Now, the reason we know that it's not in vertex form, and the reason we know that is because there's no parentheses. Usually we want to see some parentheses in order to see vertex form, which makes it much easier to graph, but we don't have it in vertex form. So instead, we're kind of on our own. Now, there's a couple of steps that you need to follow through to make sure that you can sketch something that's going to be following this graph relatively quickly. Now, the first thing that you want to do is you want to make sure that you know if your parabola is going to open up or open down. Now, the same thing that we talked about with the vertex form, you have some letters here in the parent function. Y equals ax squared plus bx plus c. A, b, and c are these coefficients. The a is going to tell you whether or not your parabola is going to open up or open down. So step 1, I'm going to look at the a value, and it's going to tell me, is my function going to open up? That's if I have a positive a. Or is my function going to open down? And that's if I have a negative a. Now, looking at it, I have a positive 2. So I'm going to have a parabola that's going to face up. Great. Next thing I want to look for, I want to figure out my axis of symmetry. Okay? It's going to be a line that goes right down the middle, crossing the vertex, and it's going to let me know that both sides should look symmetrical. Now, to figure out my axis of symmetry, there's a formula. Nope, you don't get it on the EOC, so you have to remember it. Axis of symmetry. Your axis of symmetry formula is negative b divided by 2a. So in this case, let's take a look at what our variables are. Negative b means you're going to take the opposite of what b is currently, which is negative 4. So I'm going to write negative, and then I'm going to put in the b value, which is negative 4. It's the number in front of x. All over 2 times a, which is 2. Let's simplify this. Negative times a negative makes it a positive 4 over 2 times 2, which is 4. 4 divided by 4 is 1. So my axis of symmetry is going to be at 1. So my first step is I'm going to draw my axis of symmetry. I want a nice straight line. If I had my student ID, it would be even better. So that's my axis of symmetry. It's not actually part of my parabola, but it's going to let me know that my parabola is going to have its vertex along this axis, and it's going to look symmetrical side to side. Okay? Now, third step, now that I know where my axis of symmetry is, I want to figure out, well, where is that vertex along this line? Step 3. To figure out your vertex is actually the same value that you got for your axis of symmetry. So whatever you got when you did negative b over 2a, and then what you get when you plug in that number that you got for your axis of symmetry. So the function of negative b over 2a, whatever you get when you plug in that value. So let's take a look. Since we got 1 for our vertex, our negative b over 2a, we got 1 when we did that. We want to have 1 as our x value, which we know it's going to be along here somewhere. And then we want to plug in 1, f of 1. Right? We want to plug 1 into our equation. So let's do that. I'm going to rewrite this equation on the right here, and I'm going to try and figure out what is it when I plug in 1 for x. So y equals, we can also have this written as f of x. You know, sometimes we see y, sometimes we see f of x. So y equals 2x squared minus 4x plus 5. Let's plug in 1 into all of the x values to see what we get. 1 equals 2 parentheses 1 squared minus 4 times 1 plus 5. Simplify it. Y equals 1 squared, well, 1 times 1 is still 1. So this is going to be 2 times 1. Negative 4 times 1 is negative 4 plus 5. Y equals 2 times 1 is 2 minus 4 plus 5. Y equals 2 minus 4 is negative 2 plus 5 is going to give me 3. So my vertex is going to be at 1, 3. So I'm going to go to my graph and I'm going to plot 1, 3 right here. The next thing I want to do is I want to grab my y-intercept, which when your equation is in this ax squared plus bx plus c form, standard form of a quadratic, your c value right here, that is your y-intercept. So step 4, I'm going to grab my y-intercept, which is the c. So in this case, my c, like I said, was 5. So I'm going to have 0, 5 as another point on my parabola. So put a 5 right here. Now, the next thing is, since I have this axis of symmetry, not only will I have a point to the left of this line, but I can count 1 box to the right, and then again 1 box on the other side, so it's symmetrical, and also put a point here, so that it's the same amount on both sides. So that's another point that's going to be on our vertex. So step 5 is to figure out the symmetrical point. Change my color here, 5. Okay. Plot the symmetrical point. Which in our case was at 2, 5. Now the rest of it, I'm just going to do a quick little sketch. All right, so I'm going to connect this with a nice smooth curve, and I have my little sketch here. And we're done.